Here we go. As determination of calcium isotopes by ozone reaction, ICP-QMS. I'm Yanbei Zhu. This work is done with the cooperation with my colleague, Daiki Asagawa. Because I noticed the audience come from a wide variety of research field, we'll get a little bit background about atomic analysis. Basically, there are optical analysis and mass analysis for atomic analysis. Optical analysis based on the energy variance due to the activity of electron. And for mass analysis, it's based on the relative mass, atomic mass to charge ratio. And for optical spectrometry, it has the merit of locals, but also have the demerit of low sensitivity. For mass spectrometry, they have cost high and also provide high performance and capability for isotopic analysis. Yeah, ICP-MS is inductively coupled plasma mass spectrometry. It's a powerful machine, but also full of spectral interference problems. The reason is, yes, the argon plasma provides the merit because it can ionize any element for your analysis due to its high temperature over 6,000 K. It also has the demerits because it also ionizes any element interfering your measurement. Here is an example of we only introduce pure water. If we collect the signal intensity from mass to charge ratio from 10 to 100, you see very, very strong signal intensity for many ions. So spectral interference is a big matter for determination of elements by ICP-MS. Basically, there are two major strategies to suppress spectral interference in ICP-MS. One choice is high resolution. You can increase the resolution to separate closed ion from its interferent, but it also decreases the sensitivity due to the increase in resolution. The recent availability of tandem quadrupole ICP-MS, also called ICP-QMS here, it have two quadrupole. First one, second one, sandwich the reaction cell. It can mirror the one element by setting both quadrupole to the same mass to charge ratio. For example, 56 for iron. This is called on-mass mode measurement. Another way is you set different m per z values for the second and from that of the first. Here shows the example of sulfur 32 and change it to monoxide ion mirrored at 48. This ICP-QMS provide very good capability for spectral interference suppressing. The topics of this my research is focusing on calcium here. Here shows the relative atomic mass of isotopics of argon in blue and calcium in red. The vertical x shows abundance. You see, both calcium and argon have the very high abundance of 40 isotopes. Calcium 40 strongly interfered by argon 40. There are some possible. You can mirror other isotopes, for example, calcium 44, but it had very low abundance. You also get quite a low sensitivity. Another method is cold plasma. It operates the ICP at a relatively lower temperature to suppress the formation of argon 40 ion. Also, high resolution ICP-MS is a possible way for measuring calcium. And there are reaction zero techniques changing argon to other ionic species. And here we provide a new approach is changing calcium to other ionic species based on ozone reaction ICP-QMS. The instrument shown here, I'm using adjuvant 8900. I made the original ozone feeding system to introduce online generate ozone to the ICP-QMS. The structure is like this. The bottom is ICP-QMS, and the ozone gas feeding system basically just put a ozone generator to the line of oxygen, change it to ozone, split part of this ozone introduced to the ICP-MS as a reaction gas. And the residue of this ozone is decomposed back to oxygen and exhausted as a green discharge. Here, the original ozone gas feeding system provided a typical ozone concentration about 10.5% volume percent in oxygen matrix. And the ICP-QMS here, I'm using adjuvant 8900, and other brand also may be also applicable. Here, let's have a look on the changes in product ions of calcium. When we introduce calcium, here we said the first quadrupole, the M-per-Z value to 40 to permit the path of calcium 40 and measure different ions. Calcium, for the second quadrupole, we can segregate calcium, calcium monoxide, dioxide ions. In the beginning, cell gas was oxygen. You can see if we plot the in pie chart, the major ions are calcium by itself, with a little bit monoxide, dioxide, and trioxide. This vertical X is showing logarithm scale, so it's big different. When we shift the cell gas to ozone, you can see the trioxide ion increase sharply to a very as a dominant species of calcium. So why this happens? Let's look at the thermodynamic parameters for reactions. We calculate the enthalpy for each reaction. For oxygen reaction, the change to monoxide, dioxide, trioxide are all endothermic reactions. So it goes to calcium ion by itself is a dominant species. When we change the gas to ozone, the reactions to monoxide, dioxide, trioxide are all having a negative value, that is they are exothermic reactions. So we can get a dominant result species as a trioxide, calcium trioxide ion. This slide shows dependence of the signal intensity mirrored and dependent on the radio frequency power of the ICP. When we measure the calcium to calcium, you can see the blue only 2% nitric acid, and orange calcium in calcium standard in 2% nitric acid. For calcium to calcium, it's almost no difference between the blank and the standard. For calcium to its monoxide, it's getting a little better. But especially for higher radio frequency power, you get a quite sharply increased background signals. For calcium to calcium dioxide ion can get a little bit similar to monoxide, but when we measured it as calcium to calcium trioxide ion, can get quite much improved performance for signal for standard to that of blank. Okay, if we summarize this reaction, the measurement sensitivity and blank plus 3 sigma, different plots for different ions. You can see from calcium to its trioxide, we get the largest sensitivity and lowest blank. So this permits us to measure the calcium, each calcium isotope, including calcium 40. Here's the result of a concentration of calcium in a certified reference material. The concentration obtained by 40, 42, 43, 44, 46, and 48 are all in agreement with the certified values. So the large uncertainty of about 46 depends on its very low abundance of this isotope. We also get other results for other CRMs here. Basically, they are also in good agreement with certified values. Here, summarize my presentation here. Online generated ozone was used as a reaction gas for tandem quadrupole ICP-MS. In comparison to oxygen reaction, ozone reaction greatly improves the yield of calcium trioxide ion up to over 85% due to the exothermic reactions. And variant of calcium to calcium trioxide, here loss 3, provide a high sensitivity and low blank about at hot plasma conditions. The usefulness of the method was confirmed by determination of multiple certified resin material. And we also compared the total difference about the ozone reaction with oxygen reaction. We are also carrying out the research on other elements now. Okay, thank you for your kind attention.
Thank you, Doctor. Thank you for your presentation.
Okay.
Now the session is open for queries. Any questions, please?
Hi there.
Hi.
Yeah. I also noticed that you are very professional in analyzing the ICP-MS, and sometimes because when for our experiments that sometimes I need to use the primary because I'm in material science research, so that I only use the ICP to determine the detailed atomic ratio for materials such as for the cobalt, the iron, and so. But another question is how sometimes if we encounter some very complex problems, such as for the reaction within the reaction progress, how can we use the ICP, that the signal attribution for the detailed chemical species? I think sometimes the quantitative the measurement for the signals is difficult. Do you have any other ideas?
Okay, yeah, it's especially for ICP-QMS. I mean, it have two quadrupole. You can, if you shift the M/Z value for the second one, you can detect different kind of product ions. And you can also change, if you want to identify a specific product ions, you may use like isotopic enriched cell gas. Sometimes for special purpose, I use, for example, oxygen 18, oxygen 18, yes, instead of natural oxygen with oxygen 16 as a majority. If you both compare the product ions get from both gas, different isotopic oxygen gas, you can get